Today in this video I am going to discuss about the electric conductance, and in the last video already I have defined about the electric resistance. So electric conductance is the reciprocal of electric resistance reciprocal of electric resistance is called conductance, and the conductance is denoted by capital G. So you can write capital G is equal to 1 upon R. It means the reciprocal of electric resistance is called conductance. If resistance of any conductor is more, it means its conductance is less, and vice versa. And unit of electric conductance, unit of G is reciprocal of R means resistance, its unit is ohm. So 1 upon ohm. So we can write here ohm inverse. And this ohm inverse is also called MHO. Simply you can say OHM ohm. It's reciprocal MHO. R, this one is also called, as you know, Simon. So the unit of electric conductance, you can write either mho or ohm inverse, or simply you can say this one is also denoted by Siemens, and it is denoted by S. Or simply you can say ohm inverse means you can write this one like this. So this one is a unit of electric conductance, and the dimension of electric conductance is reciprocal of resistance. So what already you have written the dimension of the electric resistance, just reverse it, then you will get the dimension of the electric conductance, which is m to the power minus 1, L to the power minus 2, T to the power 3, and E to the power 2. This one is the dimension of the electric conductance. Now the next topic is Ohm's law, and I hope maybe all of you have already studied in the class 10th about the Ohm's law, the statement of the Ohm's law. So according to the statement of the Ohm's law, if there is no change in physical state of conductor, and what physical state? Such as temperature, then the potential difference across the end of conductor is directly proportional to the current flow in it. It means suppose this one is a conductor, suppose AB is a conductor, and V is the potential difference across the end of the conductor, and suppose I is the current flow in it. So according to the Ohm's law, this potential difference across the end of the conductor is directly proportional to the current flow in it. And when we remove this proportionality constant, then here we introduce a new constant R. Actually, this R is a proportionality constant which is called resistance of that conductor. So from here we can say V upon I is equal to R is equal to constant for a given conductor at constant temperature. And when we draw for any metallic conductor, when we draw the V versus I graph, suppose this one is a V and this one is I, potential versus current graph for any metal, then the nature of the graph will come a straight line. And if the nature of the graph is coming a straight line, it means that conductor is obeys the Ohm's law. And here you can say V is directly proportional to I. And with the help of this V versus I graph, we can find the resistance of that conductor. So how can we find the resistance of that conductor if V versus I graph is given? Simply you take the slope of this line. Here should you know slope is equal to tan theta, and also you know tan theta is equal to perpendicular upon base. So for finding the resistance of that conductor, simply we calculate the slope of this line, and for finding the slope of this line, you take any 2 points on the line. Suppose A and B are 2 points on this line, and drop the perpendicular from these 2 points A and B on y-axis, means on voltage axis. And again you drop the perpendicular from these 2 points A and B on x-axis, means on current axis, and you extend this line. Then you will get a right angle triangle ABC. Suppose this angle is theta, so this angle will also theta, and the slope of this line means simply you will take in this diagram ABC, or simply in this right angle triangle ABC, calculate the tan theta. So you can say slope is equal to tan theta, and from this triangle tan theta is equal to BC upon AC. Tan theta is equal to BC upon AC. Or simply we can say here the slope is equal to, at place of BC, BC means suppose this one is V1, this one is V2, this one is I1, this one is I2. So you can say BC means V2 minus V1, V2 minus V1 upon AC means I2 minus I1, I2 minus I1. So simply you can say this one is delta V upon delta I. And this slope will give what here? Then this delta V upon delta I will give the resistance of that conductor. So if V versus I graph is given, then the slope of V versus I graph will give the resistance of that conductor. Now, if we plot a graph I versus V graph for a metal, and suppose that metal is obey the Ohm's law, then that I versus V graph for that metal, if it is follow the Ohm's law, then it's also a straight line. But in this case, when we calculate the slope, then on y-axis we will get I, and on x-axis we will get here V. So the slope of I versus V graph will give the conductance of that metal. And you know, conductance is the reciprocal of resistance. It means when we calculate the slope of I versus V graph, so again we will take the 2 points on it. Suppose A and B is the 2 points on it. Suppose A, this one is B. Again in the same way we will drop the perpendicular from point A and B on y-axis. Suppose this one is I1, this one is I2, this one is V1, and this one is here V2. This one is measured in volt and I is measured in ampere. And again when we extend this one, we will get a right angle triangle ACB. And again the slope of this one, slope is equal to tan theta, and again tan theta is BC upon AC, and this slope is equal to BC means again we will take this distance, which one is I2 minus I1 upon AC. AC means this one, which is V2 minus V1, and this will give delta I upon delta V. And this delta A upon delta V, this is the slope of I versus graph, which is equal to R. This one is equal to conductance of that metal. It means slope of I versus V graph will give us a conductance, which is represented by G, and we can say delta I upon delta V. And if you want to find out the resistance from I versus V graph, then simply you will take then R is equal to 1 upon G. And this one is what here? Unit ampere upon volt. And when you will calculate resistance with the help of this I versus V graph, then simply you will take the reciprocal of this conductance is called resistance. So in this way, if any graph is given, either V versus I graph or I versus V graph, then with the help of that graph you can find out the resistance of that conductor. This is very easy. And remember this, if suppose V versus I graph is drawn like this, suppose this one is V versus I graph, this one is drawn like this for two metal. So out of these two metal A and B, slope of B is more than the slope of A. It means if the slope of B is more, and this one is V versus I graph, V versus I graph means the slope of V versus I graph will give the resistance. It means resistance for this conductor is more than the resistance for this conductor. But if the same graph is given I versus V, and suppose one is this one is this one is A and this one is B. Now here slope of B is more, and this one is I versus V graph, and if slope of B is more means conductance of B is more, and if conductance of B is more, it means its resistance is less. So here resistance of B is more than the resistance of A, but here the resistance of B is less than the resistance of A. So in this way, if any graph is given, either V versus I graph or I versus V graph, then by calculating their slope we can calculate either the resistance of that conductor or the conductance of that conductor. Now some important point or some note I want to give for this one, and in which the first point is what here. First point, Ohm's law is not a universal law. Not a universal law means Ohm's law is true only for metallic conductor. So simply you can say Ohm's law is not universal law because it is true only for the ohmic conductor. Second point, this formula V upon I is equal to R. This one is not the statement of the Ohm's law, because a conductor obeys Ohm's law only if its V versus I graph is linear, means straight line. So simply you can't say here V upon I is equal to R is the statement of Ohm's law. Merely this one is not the statement of Ohm's law. Any conductor obey the Ohm's law if its V versus I graph is linear or straight line. And third point, this relation V upon I is equal to R is the definition of resistance of a conductor, whether the conductor obey Ohm's law or not. It means with the help of this one we can find the resistance of any conductor, either that conductor is obey the Ohm's law or not. So in this way, please don't put this misconception in your mind that V is equal to IR is the statement of Ohm's law. This statement is not the statement of Ohm's law, or this formula is not the statement of Ohm's law, because it is true for both ohmic as well as non-ohmic conductor. And simply you can say R is equal to V upon I, and with the help of this formula, this one is simply used for finding the simply used to define the resistance of a conductor. And last thing is what here, non-ohmic conductor. So non-ohmic conductor are those conductor which does not obey the Ohm's law. And for non-ohmic conductor, the V versus I graph is not linear. This one simply comes, comes like a curve, like this, so sometimes it comes like this one here. Or there are so many example of this non-ohmic conductor, like torch bulb, diode, vacuum tubes, thermistor, semiconductors. All these are the example of non-ohmic conductor, means it does not obey the Ohm's law. So dear student, today you go through all these points which just I have discussed in this video, and this one is the basic things because already you have studied in the class 10th about this one. In next video again I will discuss the next topic. Thank you.